Hey guys, this is still number 12, but now I'm on the part where we graph the cost and the revenue, and then we shade the profit light and the loss dark, and then we find these things called break-even points. Okay, so I already did this, but my phone died, of course. So let's go ahead and draw a little graph. And remember, when we're talking about the real world, we only really care about the top right quadrant. So I'm just going to draw a top right quadrant. Here we go. And then in the words, it says graph the cost and the revenue for 0 less than or equal to X less than or equal to 8,000. That means our graph is going to start at the X value of 0 and end at the X value of 8,000. Okay, so we are going to plug in the cost. So our cost is from the very original problem, 112,000 plus 70x. Let me just write it down. Okay, and then the revenue we found earlier also, not the marginal, just the regular revenue. The regular revenue. It still has a squared in it probably. So R of X equals negative, I think ours was 0.05 X squared plus 400X. Okay, so now we're going to put both of these in Y equals. Okay, if I go to press graph, I can't even see anything. Well, I can see a line, but I can't really see anything. So I need to go to my window, and where it says X max and X min, I'm gonna put this 0 and 8,000. So for my X minimum in my window, I'm gonna put 0. For my X maximum, I'm gonna put 8,000. So I'm gonna press this window button beside the Y equals window. And next to the X min, I'm gonna put 0. Then X max, I'm gonna put 8,000. Okay, let me also see, okay, I'm cool. Okay, now I'm gonna graph it, and I still don't see much. Okay, and that's because I fixed my x-axis, but I haven't fixed my y-axis. So for your y-axis, the y min and y max, one way to find it is just to look at your answer choices and see how high they go on the y-axis. The y minimum is still 0. I'm guessing your graphs go up to, I don't know, 150,000 maybe 200,000, maybe 500,000. Let me see. So I'm going to press my window, and at Y minimum, I'm going to put 0. And at Y maximum, I mean, I'll try 500,000, but I don't have my homework problem in front of me. So whatever your highest Y value is on all your graphs in your multiple choice, that's the Y max. Okay, so I put 500,000, and okay, there's my straight line. Oh, and I don't quite have all of it. Okay, so I'm gonna go back to my window, and I'm gonna change it from 500,000 to maybe 1 million. Okay, let me try. Oh, hey, good looking. Okay, so my Y minimum was 0 and my Y maximum was 1 million. That's 1 with 6 zeros. Okay, now we're gonna graph this. Let's draw it. It looks like it goes and something like that. Yeah, okay. So on these light up calculators, it's real nice because it's color coordinated. If I go back to Y equals, Y1 says blue, and the blue is the line. Woohoo! Or if I go back to Y2, I see that the squared thing is the red, and the squared thing is the hump. Or for those of you who don't have a backlit screen, if it has a squared in it, then it's the hump. If it doesn't have a squared in it, like this cost, it's a line. Okay, so we were supposed to graph. Let me just label these suckers. This C of X line is the cost. This hump is the revenue. Okay, so we pretty much graphed it. Awesome. Now we have to just shade profit light and the loss is dark. Well, I think we already talked about this in one of the videos, but profit is the portion that is above the cost line. So if I'm looking at this cost line, profit is all this blue stuff up here. And any part of this hump that's below the line is the loss. Or if we look at this sucker, the cost is the line, revenue is the hump, you know, but anything above this line, like this blue stuff, is the profit. Anything below is the loss. So let's go back to ours. Here's my cost, and anything above this cost, anything above this cost line is profit. Okay, profit. Okay, anything below this line, as in maybe this and this little smidge over here, this is loss. Okay, now let's talk about your break-even points. Break-even points happen when you make no profit and you lose no money. You made, like, you know, $0 profit. Yeah. So that happens when the hump meets the line, or right here when the parabola crosses through that line. There's actually two spots, one here and one here. Okay, so to find the break-even points, there's actually a lot of math involved, but we're not doing that. No. We're just going to go back to our graph, and I'm going to try pressing trace, and hopefully it'll get me to exactly these points. If not, there's another trick I can use. So let me press trace, and let me just slide up that little flashing dot until where they kind of touch each other. I think this is as close as I'm going to get to them touching each other. You should have numbers at the bottom. Those numbers make up the point, the X comma Y. So I have like 6242. So 6242.42. I don't know what your homework makes you round to. Comma, then the Y value says like 5489. Yeah, okay, I'm going to write that down. 548,969.7. So there's one break-even point. Now I got to find this other break-even point. So let me scroll backwards. Ooh. Oh, getting close. I think my closest I can get is maybe 424 is the X value, and the Y value is something with a 14. So 424, and then I think there's a 0.24 with a 14, 16, 96.97. Hey, so these are our break-even points. As in when we sell this many items, we don't make any revenue, or sorry, when we sell this many items, we don't make any profit, and we don't lose any money. So we have a break-even point because no profit happens, no loss happens. And it probably happens when we've sold 6,242 lawnmowers and we made a revenue of, gosh, $548,969. And then also We probably would have a break-even point at 424 lawnmowers that brought in a revenue of 141,000-ish. So this would say anything 424 and less, we're going to lose money. So over here, this little loss area represents from 0 to that 424 lawnmowers. And that's when we're losing profit. Then anything from 424 to 6,242 lawnmowers will make a profit. But then after 6,242 mowers, we're not gonna make a profit anymore. We're gonna start losing money. Okay, let's look at part J. Part J says profit, as in P of X. Well, they did not give us the equation for P of X, but we can come up with an equation for P of X. If I want to find the profit, I'm going to take the revenue minus the cost. And we know both of these equations. We just use them. So P of X is the revenue minus the cost. And that revenue was that decimal with the negative and the squared in it. Look back at it. The revenue was negative 0.05x squared plus 400x. That's the revenue. Then I'm going to put a fat minus, and then I'm going to put what my cost was. And my cost function was that C of X, and it was 112,000 plus 70x. Okay, now I'm just going to distribute this negative and combine like terms. So I'll get negative 0.05x squared plus 400x. Then the negative multiplies with the 112,000. Then the negative multiplies with that 70x. It makes negative 70x. Okay, now let's just combine like terms, like the 400x and the minus 70x. That can make a 40 minus 7, 330. So this is negative 0.05x squared plus 330x minus 112,000. Hey, and that's my profit equation. Okay, now let's look for marginal profit. Marginal means derivative. So we're just going to take the derivative of this sucker. So to take the derivative of this sucker, we take the exponent and bring it down and multiply it with that negative 0.05. So P prime of X is I take this 2 and I bring it down in front and I multiply it with this negative 0.05. And then I subtract 1 from the exponent. So 2 minus 1 is 1. So we have x to the 1. Then we learned that the derivative of a number and an x just goes straight to the number. So plus 330. Then we learned that the derivative of a naked number just goes away to 0. So our marginal profit is whatever 2 times negative this is, which is negative 0.1. And then there's an x. I don't have to put the 1 in the air. And then plus 330. Hey, this is your marginal profit. Okay, now let's look at L. It says P prime and P prime, and then add some numbers in parentheses. Well, that means we have to use our P prime equation, which is what we just did. That P prime of X was negative 0.1x plus 330. And now we're going to plug in these numbers into the letter X, use our calculator, and then, yeah, let's go. So P prime of 2100 is equal to negative 0.1 times 2100 plus 330. Then P prime of 4200. You might think it's double. We shall see. Okay, so I'm just going to go back to my blank screen. And when you type this negative on this 0.1, make sure you type the negative by the decimal button. And I got 120. And then for the next one, I got negative 90. What? Okay. So what this means is the number in the parentheses is the amount of items. And I think this word problem is talking about lawnmowers or saw. Nope, talking about saws. Okay, so what this means is 2,100 saws and would have a marginal profit of this 120 is $1 amount, so $120. Then for the next sucker, it's 4,200 saws at a marginal profit of negative $90. Okay. Let's keep going to another problem. Okay, another problem on your homework has to deal with hamburgers, and it's a lot, so I'm gonna go ahead and do it also. Okay, so this one's tricky. It says, example, hamburgers cost $2.50 each. And when they're $2.50 each, they sold an average of 22.50 hamburgers. Okay, well, they increased the price of hamburgers to $3.10. And when that happened, sales dropped, and we only sold an average of 1,950 hamburgers. 1,950 hamburgers. Okay, then there's something called a fixed cost, which is 2,152.80. Fixed cost means like how much it costs to pay the rent, how much you have to pay your employees, how much it costs for utilities like electricity, water, how much it costs for the materials. That's fixed cost. Okay, and then we have something called variable cost. That's $1.82 per hamburger. $1.82 per hamburger, as in maybe for that specific hamburger, the pickles cost extra money. So for every hamburger that has pickles on it, it's an extra $1.82. Whereas the hamburger with no pickle would not have that $1.82. Okay, so the first thing says, what's the price P and demand X? Or it says the price P and the demand X is linear. P equals question mark. What? Okay, so this threw me for a loop because I don't have any equations. I just have a bunch of numbers. Goodness. Well, the key word here is linear. And linear means it has a slope. Okay, well, the slope formula, we're just going to go back to basic slope formula. We're not doing all those crazy formulas from earlier. We're just going to go to y2 minus y1 over x2 minus x1. Remember this sucker? Yeah. Okay, so we're going to try and find our slope. Then we're going to throw it into y equals mx plus b. Yeah. Okay, the only thing is, where's my points at? I don't have anything. Well, my points come from the hamburgers are $2.50 each, and we sold an average of $22.50. Okay, then when the price of hamburgers was $3.10, we sold an average of $19.50. So those actually make 2 points. Okay, this first point, if we look at this graph, the x value, instead of like a x comma y, we're gonna have the number of hamburgers comma the price of the hamburgers, because the x value is the demand, or how many hamburgers you sold, and the y value on this graph is the price, or how much we sold them for. So if we look at this these first two bullets, it says they were $250 each, so that's comma $250. And when they were $250 each, we sold 2,250 hamburgers, 2,250 hamburgers. Hey, that's a point. Now let's make a point out of this next sucker. It says we sold an average of 1,950 hamburgers, and they cost $310. Okay, well, these are our points. Yeah, this 2,250 and 250, yes, that's X and Y. Both of these are X and Y. But this first point is X1, Y1. This second point is X2, Y2. Okay, now that we have that figured out, let's throw them in the formula. So our slope, or our letter M, is Y2, 310, minus Y1, 250, all over X2, 1950, minus X1, 2250. Okay, let's do the math. I think on the top, you just get 0.60. Did I do that right? Yep, okay. And on the bottom, we get negative 300. Okay, now that's not a slope. Remember, our slope usually looks like, I don't know, whole numbers in a fraction. This is a decimal. So let's divide it. Okay, so I got negative 0.002, and that's my letter M. Okay, it's asking for the equation, as in y equals mx plus b. Well, I know what my M is. It's this decimal we just got. So let me put that in there. I know what my Y and my X are because I can take them from one of these points. I either take my Y and my X from the first point or from the second point. I don't mix and match from different points. Okay, so my Y, I'm just gonna say is 250 equals, then this is my slope, and then my X value for that 250 was 2,250 plus B. And then now we're gonna get our B by itself. Okay, so this gives me 250 equals negative 4.5 plus B. And then get B by itself by oppositing that negative 4.5. And when I do, I get 6. 7 equals B. Okay, let's throw it into the equation. We are now going to have Y equals, what was your M? That decimal. Then it says the letter X. Then it says the letter B, which is a plus 7. The only thing is, these letters don't look like the letters on your graph, and that's because the Y value on our graph is actually the price, the P. So all I'm gonna do is, instead of this Y, I'm gonna put a little baby P. And hey, that is the price demand equation in terms of P, or P equals. Okay, if I wanted to graph this, I just throw this in my calculator. And I probably need to fix my graph. I think I'm gonna just take it back to normal. Zoom standard, so zoom 6. Yeah, okay. Can't really tell. Maybe let me press zoom, the top right quadrant. What is that? Zoom quadrant 1. Okay, well, you can't tell. That was horrible. But it's supposed to be a line with the y-intercept at 7, as in somewhere up here, and then a slope that's negative, as in it goes down. So I know that I'm right when my line goes down, because look at the beginning of the word problem. It said When we raised the price, the sales dropped, as in our line goes down. Okay, now it says, what's the domain of this sucker? Well, the domain is the X's. And we know that in real life, our smallest X value is 0, because you can only sell 0 hamburgers. You cannot sell -1 hamburgers, -2 hamburgers. We just have to figure out what the maximum amount of hamburgers is I can sell. So we're going to look at that P equation that we had, and we're going to try and find when it lands on the x-axis. Another way of saying when it lands on the x-axis is x-intercept, or the y value is 0 right here because you do not go up or down. Another way of saying the y value is 0 because this point does not go up or down is to say the P price is 0, as in we're gonna plug in a 0 for P. I think on one of the other videos I did it using the calculator, and I'm just showing you a different way. Okay, so let's put in a 0 for this P equation. For the letter P, 0 equals -0. Okay, now we're going to get X by itself. So I'm going to subtract 7. And I get -7 equals -0.002x. But then how do I get rid of a decimal that's multiplying by my X? I divide by that decimale. And let's see, it cancels out on the right, and we get $3,500. So what that means is when this line hits the x-axis, 3,500 hamburgers have been sold. And then if the line keeps going, we would have a negative price, and nobody sells things for negative prices. So that's why we want that point, that x-intercept, where the line touches the x-axis. So this is saying that that line goes from 0 to 3,500. That's the domain. Only we need to use it, write it using some alligators. So maybe 0 less than or equal to x less than or equal to 3,500. Hey, that's the domain. Okay, now let's go to part C. It says, what's R of X? Well, R of X means the revenue. And revenue is 2-1 formula. Where's my piece of paper? Oh, here it is. Okay, let's look at how to find revenue. Oh, it's right here. How to find revenue. You multiply P. Okay, let me write down my P. P was, so let me write down my P. P was -0.002x plus 7. And we're supposed to multiply it with something. So we're going to multiply this P with X. Not the X equals price demand equation. Just multiply by a negative X letter. Okay. X. So we're just going to multiply this with an X. Okay, let's go. This decimal X times another X makes the same decimal, but with a squared, because you multiplied 2 X's together. Then this X multiplied with this 7 is plus 7X. So it's kind of like we distribute backwards. Yeah. From the right to the left. Isn't that weird? Okay, so this is R of X. That's our revenue. Now let's ask, what's the domain of the revenue? Well, I think you saw that on number 12, the domain of the revenue should be the same domain as the price demand equation. But let's check it. I'm going to put this equation in my y equals. I'm going to graph it, and I'm going to see if the x-intercept was at 3,500, like the last picture was. Well, okay. I graphed it, and I can't see anything. It's probably because of that window. Let me go to my window. And I'm going to change the x max to maybe 3,500. From our domain from part B. And then now let's graph it. Where is it at? X max. Let me maybe put 5,000. I don't know. And then let me try to do, what does it look like our highest Y values are on these suckers? It looks like my Y values are like $2.50, $3.10. So maybe I just say the Y max is maybe a little bit higher than that highest one at 310, maybe 5. Okay, now let's graph it. What is my problem? Oh, I can see it a little better, but it's not high enough. So let me go back to my window and change Y max to maybe 10 or 20. Nope. Okay, well, oh, okay. I'm having to change my calculator back. I will tell you what I'm doing in a minute. Yeah, I don't know what's wrong with my calculator. Okay, it's probably just me. Okay, well, on the last example on number 12, we saw that the domain of the revenue is the same thing as the domain as the price. So we're just going to say it's 0 less than or x less than or equal to that last domain we got, 3,500. Woohoo! Okay, let's see what's next. It says the cost is linear. What is C of X? Okay, well, if it's linear, that means it looks like Y equals MX plus B, where B is the fixed cost number that they gave us, and M is the variable cost that they gave us. And then Y, we're just going to use that C of X instead of the letter Y. So because they said that cost is linear, that means I'm going to try and make up a Y equals MX plus B equation. So let's see here. Instead of Y equals, I'm going to say C of X. Instead of M, I'm going to put whatever the variable cost is, as in it could change depending on the type of hamburger you have. So ours is $1.82. Maybe this hamburger has an avocado on it, okay? Then X plus the fixed cost is how much it costs to pay your employees, pay the rent, pay the utilities, pay the water bills, stuff like that. And that's $21.52.80. Hey, baby, there you go. There's the cost function. Okay, now it says graph the cost in the revenue. Okay, well, the cost is what we just got. I'm just going to write it down so I don't have to look back at it. And the revenue is that R of X that we got on the last page. And it was not the marginal, not the one with the tick mark. The one that says negative 0.002 x squared plus 7x. Okay, so we're going to graph these on the same graph. Let's go. Hopefully I can get my graph in order. So I'm going to put in this 1.82x plus 7x plus 7. No. 1.82x plus 2152.80. Then on the next one, negative 0. Okay. Then I'm going to graph it. It's probably not going to work. Yep, it didn't. Okay. I'm going to go back to my zoom, and I'm going to say zoom 6 standard. Okay. Then what I'm going to do, oh, I can see part of it. Then what I'm going to do is I'm going to change my domain, or the X-min and the X-max, because earlier we said that our domain was 0 to 3,500. So I'm going to press window, and my X-min should be 0. My X-max should be 3,500. Now I'm going to graph. You can barely see some stuff, but it's over there. Okay, so I can't quite see everything. It's supposed to be a hump up and a hump down. And it looks like I have like the legs of the hump, but I don't have the top of the hump. So I think I'm gonna change my Y value, like the highest Y value, to something big, and my lowest Y value to only 0, because I only want this top right quadrant. So I'm gonna go to window, and I'm gonna change my Y min to 0 and maybe my Y max to 5. Let's see what happens. Graph. Nope. Okay, let me try my window. Maybe my Y max is 50. Okay, it's getting better. Let me go back to my window and change Y max to maybe 1,000. I'm getting impatient. Oh my gosh. Okay, let me change it again. Oh, and if you already have pictures on your homework for multiple choice, just look at that Y value and that's your Y max. But I don't have it with me, so I think I'm just gonna try maybe 10,000. Oh, hey, good looking. There she is. Okay, so my X-min was 0. The max was 3,500. And that came from the domain. Then my Y minimum was 0, because we only want the top half of the graph. And then my Y maximum had to be big. It was 10,000. Okay. So let me draw my picture. It looks like, and then habit. Okay, there we go. Yeah. Okay, and cost is the straight line, remember? And revenue is the one with the square. It's the hump. So revenue is this little humpy hump. Okay. Now it says, what are the break-even points? Well, the break-even points are when you stop profiting and you start losing money. Well, profit is the part of the hump above the cost line, and loss is the part below the cost line. So this pink is the loss on both sides, and then this little blue stuff is the profit. Well, we want to know the exact point when those two meet, as in when we have 0 profit and 0 loss. And there should be 2 spots. So we're going to go back to our calculator, and we're just going to press the trace, and hopefully this little flasher can find us somewhere good. Okay, it looks like I got 2068.18, comma 5916.89. Okay. Then I'm going to move my flashy button over here on the left, because that's technically a break-even point too. I don't know, maybe 530.30 and 3117.95. And remember that these first numbers are like the amount of hamburgers, and this second amount is dollars. So this is saying when you sell 2,068 maybe 2,069 hamburgers. And anything after, you're losing money. If you sell anything from 0 hamburgers to this 530 hamburgers, you're losing money. You're still bringing in a revenue, like for 2,069 hamburgers. We're losing money, but we're still bringing in revenue. We're still bringing in $5,916 that night. It's just that the cost to make the supplies was higher than the revenue. So we lost money. Okay, P of X. Well, P of X is found by, let's see, revenue minus cost. Well, we already have our revenue. It's the one with the squared. Then I'm going to put fat minus, and then we already know our cost. It's the one with the $1.82x plus 2152.80. Okay, then we're going to distribute that negative, and we get that negative decimale minus $1.82x minus 2152.80, because when you distribute a negative, all these signs change, because this is a negative times 2 positives, so they become negatives. Okay, now let's combine like terms. I think these x's can combine, so we're gonna get 518, like a plusative, so 5.18x. Bring down your naked number. Bring down that squared number. And hey, this is our profit equation. Woo. Okay, the next piece says, what's the marginal profit? Well, marginal profit means derivative. So let's take the derivative of this. Or did we already? Nope, we haven't. Okay, so to take the derivative, you're gonna bring the 2 and multiply it down in front. So negative 0.002 times 2 is negative 0.004. X to the, we're taking the derivative. Subtract 1 from the exponent, 1. Then the derivative of a number and an x is just a number. The derivative of a naked number flies away, goes to 0. Okay, so this is the marginal profit. It's the derivative. Now I'm going to plug in that 570 hamburgers. And I get 2.9. And let's remember that the X value of this problem is hamburgers. So this is saying when you have 570 hamburgers, and then this 290 is actually a dollar amount. As in when you have 570 hamburgers, your marginal profit is $2.90. Okay, thanks.